Christmas tree. Isn't it nice? Okay, let's start with the sockets for the lamps. Done. Lots of cable, lots of lamp sockets. Okay, next up, that little guy. Sorry, forgot to press record. Not much happened. I just put the outer screws in to the case, so now the cage can be fitted for can be screwed down from the outside, but it turns out it's a little bit too tight of a fit. So I will have to yeah, drill these 4 holes again with yeah, let's first try 2.5 millimeters. Okay, I can bend it back into shape anytime. Now it's just a question of the fit. So with 4mm screws. Oh, much better. Much better. Question is, messed I up the finish? No, not really. Wonderful. Now the only things missing are thumb screws. So, top side is finished. Yeah, easy changeable light bulbs, because the light bulbs are also the fuses in that whole contraption. So, next stop would be bottom part. So, yeah, the front. Let's start with the small pieces. You remember my plan. So these have to go in with a little slot on the top. So, wonderful. 5 switches, index slot are all on the top, like indicated in the drawing. So if I wire it up correctly, top should be 12 volts, down should be 24 volts, 20 watt each, and middle should be off. The big guy. Yeah, I may have to rework on that a little bit, but for now it's okay. Only thing is the space requirements, but that seems also to be okay. Yeah, it will be all a tight fit, but it will fit. It fits. And finally, the binding posts. So, yeah, one could adjust these things a little bit, yeah, clean it up, and yeah, but since I'm planning to do some yeah, lettering here on the front plate, that's not important for the moment. Important is we can start to wire the whole thing up. Yeah. So, time to put everything together. Some changes to the plans. That was my initial drawing, if you remember. And yeah, I had that bridge directly on each switch on the top, which would be kind of a hard. I mean, the bridges would be easy to put in, but then I have to solder to the bottom pins of the switches. So yeah, I redesigned the whole thing in that way. So I turn the switches 180 degrees, and yeah, of course I had so I have the bridge on the bottom, and of course I had to rewire the rest accordingly, and I changed the colors. So neutral, yeah, AC is now blue, as it should be in Europe, and black, or we will partly use brown because I don't have a thick black wire. Yeah, so the live wire, live, uh, is black. Yeah. So first I need my bus bar here for neutral and live, and connect that to the live to the switch. So yeah, I have here some electric wire and obviously no tools. Just a second. Now I have my tools, and basically we want just a little bit of bus bar for, yeah, wrong color, the neutral on the last 5 pins, and then we will connect the light bulbs to that. So now we do the same thing for neutral. Okay, I'm not absolutely happy with the isolation properties here and here. Maybe I put some sleeve at the end of the cables, but for now I have my bus bars, and this goes to the neutral input, which is the lower one, so yeah, there's a little bit of space. So now we have to connect well, from this perspective, the upper light bulbs to the bus bar, to the live bus bar, which is, well, I only have a brown cable, no black cable. Okay, that was my live side, and now we can do the same for the neutral side. Okay, that's the bus bar. What next? I guess we put the bridges in on these thingies here, but I first have to get them out again. Yeah, I will be using some 22 wire gauge hookup wire. It's American. That's the reason it's not in square millimeters, but in wire gauge. And yeah, this will be a little bit of tedious work. Now imagine doing that in some shitty factory in China all day long. I mean, it's no wonder you don't want it, your work to be, to be good, to be working. You just want to get to the number of switches you're assigned to do, and to your shift to end. Yeah. Well, I get these back into the case, and then we do the rest of the wiring. Okay. Now we can connect the bulbs to the switches, and according to plan, the ones connected to live go to the left side. And yeah, I won't be able to put the wires into the eyes, so just as a security measurement, afterwards I will put some heat shrink sleeve over the contact. So it's a good idea to put the heat shrink tubing on before you start to solder. And on a side note, I also put some heat shrink tubing here on the big wires on the bus bar, because I was a little bit concerned because they are so close to the nuts here. Yeah. Well, if this cable would have been just a wee bit shorter, I would have been in kind of a tight spot, wouldn't I? But yeah, just fits with the open case, which is good. Now, the connections from the upper left of the switches to neutral. And well, I decided to do 5 wires because daisy chaining that with a thick wire would be, yeah, kind of a mess. And yeah, this is 24 wire gauge, 0.2 square millimeters. That should be enough. I mean, each switch is, each side of the switch is only less than an amp, so yeah. Okay, now some black wire from the top right to live. So, and while we are at it, we also need a length of wire from live into the main switch. Okay, now it's time for some crimping, especially the connection to the main switch, and maybe we can clean up that mess here a little bit with some heat shrink tubing. We'll see. Okay, let's continue here. I'm not quite sure if I get all this with these cables too crimped. Well, let's try it. Probably not, huh? Okay, that seems to be better. Time to actually put the heat shrink on in the different places. Only one solder lock left to do. I think we got everything. It's time to assemble. the last connections. Okay, I believe that's it. Oh, look, things are falling out. That's interesting. Oh, see. There are still some loose screws. That's not good. Yeah, let's tighten them up too. I just don't see anything else loose. But I lost the nut somewhere on the ground, so... So I just shook it because I wanted to make sure that there's no solder stuff or you know, cut off wire left inside, but obviously it was also a good test to see if I really fastened all screws. Okay, another shake test. Okay, everything's hunky-dory. Looks nice. I mean, just imagine, not too long ago, all electronics were built this way, with this solder posts and yeah, all stuff wired up by hand. Okay, time to close the whole thing up, which is probably also a tight fit. But a fit nonetheless. Okay, let's get over to the other desk and yeah, close it up and play with it a little bit. So let's put the thing together. So, almost ready, huh? Let's see if we have any dead short from the start. Nope. That's a good sign. So, let's put the light bulbs in, huh? I have 10 spare bulbs, just in case. Okay, everything's in neutral, and if I flip the big on switch, nothing should happen. Okay, the first pair in 24 volts. That's disappointing. Oh, obviously. I put that switch in the wrong way. Ooh, that's really disappointing. Getting the switch out and turning it might be a bit of a mess, but we'll see. Yeah, so this is on position. No, which is correct. Off should be down, on. Neutral, off. Okay, so we have 2.6 volts. And downwards we have half of it. Yeah, that's right. 24 volts, 12 volts. Off. Yeah, almost finished. Okay, one last touch is missing. Just a second. Some case feed. So, I think we are ready to light up the Christmas tree. And what better way to do it than using the vintage power supply I'm currently trying to build a new linear regulator for. Yeah, this should be all good for 5 amps, but it's breadboarded, so we'll see what blows up. Here goes nothing. So it's still off, and yeah, the maximum I get out of here is 13 volts at currently. Yeah, wrong. Cannot see it. Sorry, wrong. Still the old potentiometer here. But anyway, let's try to tweak it to 12 volts. Yeah, the potentiometer has seen better ways. Main switch on, and we go for 22. Wow. Either okay, that's better. So downwards is 12. That's not what I wanted. But okay. And upwards, it's the 24 volt position. So obviously it's good for 5 amps, and just checking. you know. Yeah, everything's still cool enough. So yeah. Oh, do you see how my voltage is breaking it? Christmas tree. Isn't it nice? Ooh, that's not looking good, is it? But as I said, breadboard, small wires. Anything getting uncomfortable? No. Yeah, the rectifiers get a little bit warm. That's okay. Nothing gets hot. That's also good. But yeah, I guess there are too many internal resistances here going from the breadboard inside. But yeah. And again, low resistance, 12 volts, is down. So yeah, it's exactly as I wanted it, isn't it? Smaller load is up. So let's see if we can coax it to deliver 5 amps. No, we can't. Ooh, yeah. Sorry, sniff test. Yeah, the rectifier is getting warm. The current regulator is not really warm. And the power train is at the back. Yeah, you can feel it, but it's okay. Let's see if the current limiting. Oh yeah. Yeah, still a lot of work to do, huh? Look at that. But it's not behaving in a linear fashion. The current limiting, that is. So there's still work to do. Yeah, well, shit happens, but I have electronic load and an electric load, and yeah, that's also still touchable, so this works too. Oh, isn't that nice? And yeah, one more piece together in rebuilding that vintage power supply. And obviously my current limiting is working like shit, and I have no idea why. I have absolutely no idea why. And the voltage regulation is also a wee bit off, but that could, as I said, as well be all the contact resistances from these from the binding posts to the breadboard. I mean, it's all a little bit, yeah, not how you would build a 5 amp 30 volt power supply. But anyway, goodbye shot. Thank you for your time. That was fun, and yeah, it works. Bye.